everybody, and welcome to this video on functions. In this video, we have a look at inverses, and specifically the inverse of the hyperbola. So let us have a look at this graph here that we have. Now, as you can see for this graph here, it's a parabola with the p-value of 0 and a q of 0. If you do not know what I'm talking about, please watch our previous videos on the hyperbola's properties. So a graph with those parameters is just written as f is equal to a over x, and the parabola has an axis of symmetry of y is equal to q. So y is equal to 2 is the axis of symmetry of this hyperbola. So when we reflect it about the line y is equal to x, which is what we do to get an inverse, that we get the same graph. So the inverse of f of x is equal to a over x is still a over x, and y is because it's already symmetrical about the line y is equal to x. So what we're also going to note is that the inverse of a hyperbola is still a hyperbola. And in general, how do we get the inverse, which is a reflection about what y is equal to x, is we start with f, swap x and y, and solve for y, and what we're going to be left with is an inverse for f. So when f of x is equal to a x over x minus p plus q, and we have different parameters for p plus q, we can get different graphs. So let's have a look at an example. So here we have f of x is equal to 3 over x minus 2 plus 1. So let's quickly just talk about some of the properties of f. So f has two asymptotes. So the asymptotes are, and you should know how to get this. If you're not sure, then please watch our previous video on the properties of the hyperbola. So it's very important to know the hyperbola before you learn the inverse. So the one asymptote is x is equal to 2, and that comes from our p-value, and the other asymptote is y is equal to 1. So the domain of this graph is x is an element of real numbers. So for hyperbola, it takes all real numbers. The only thing is it does not equal to the asymptote. So it won't touch the asymptote. And the range is y is an element of real numbers. The only thing is it will not touch the asymptote. So those are the properties that we kind of have from this hyperbola. Let's go ahead and find the inverse. So to find the inverse, what do? We swap x and y, and we solve for y. Let's do that. So in the place of y, we're going to put x, 3 over y minus 2 plus 1. See, we have swapped x and y. So now I'm going to take the 1 over, and I have x minus 1 is equal to 3 over y minus 2. I want the y in the top, so I'm going to invert both sides. So this becomes 1 over x minus 1 is equal to y minus 2 over 3. So I tipped over both fractions. Remember, x over 1 you can always write as x over 1, x minus 1 over 1. Anything you can write it over 1, and then that fraction I tipped over, and this fraction I tipped over. So then I'm going to multiply both sides by 3. So I get 3 over x minus 1 is equal to y minus 2. And finally, I'm going to take that 2 over, so I have y is equal to 3 over x minus 1 plus 2. So our inverses equation, is equal to 3 over x minus 1 plus 2. Now look at this. What are the asymptotes of this graph of f inverse? The asymptotes are x is equal to 1 and y is equal to 2. What do you notice when comparing it to the original graph? So have a look at them. Can you see they swapped around? That the old one had x is equal to 1 and x is equal to 2 and y is equal to 1, and the inverse has it swapped around. So x is equal to 1 and y is equal to 2. Let us get the domain and range. So the domain is x is an element of real numbers, but x is not equal to 1 because this is still a hyperbola. And the range is y is an element of real numbers, but y is not equal to 2. So what I hope that you see, that everything that belongs to x in the original graph now belongs to y in the inverse. So the domain is like the range of the inverse, the range of the original is like the domain of the inverse, the x-intercepts become the y-intercepts for the inverse, the y-intercepts become the x-intercepts for the inverse, all because we're reflecting an inverse is a reflection about the line y is equal to x. So whatever then used to belong to x will now belong to y, and whatever used to belong to y will now belong to x in the inverse. So I hope you've understood this video about the inverse of the hyperbola. If you are uncertain about the properties of the hyperbola, start with that video before watching this one. And if you have not understood it, try watching it one more time. And if you have, please enjoy the rest of our series.